Solving linear inequalities. Made easy. Example number 1, we want to go ahead and solve this problem right here. So we treat linear inequalities basically the same as linear equations. This you can kind of think as like the equal sign. So what we want to do is get x on one side and put everything else to the other side. So let's go ahead and begin doing that. I want to move this negative 11 over to the other side. So you always do the opposite. So this is minus 11. That means we're going to add 11 to both sides. Like that. These 11s are going to cancel. And what we're going to have left over on the left-hand side is 7x. And then we write down our inequality there, which is less than or equal to. Negative 32 plus 11 is going to give us negative 21. And now we have 7 times x, so that means we do the opposite, which is division, to get x by itself. So we're going to divide by 7 to both sides. These 7s cancel. What we have left over is x is less than or equal to negative 3. Now, there's going to be, I guess, 3 different ways to write down our solution. This right here is one of the ways. Another way is to use a number line, which would look something like this. Here is 0. I'm going to say this right here is negative 3. And with the number line, basically what we're doing is we're trying to visually show what our answers are. So in this case, it's saying x is less than or equal to negative 3. So that means x is going to be less than negative 3, which is negative 4, negative 5, negative 6, so on and so forth. But it's also equal to negative 3. So that means when we write down our number line, negative 3, we're going to put a circle, but we're going to shade the circle in. That represents that negative 3 can be an answer. And then we can go ahead and draw another arrow. And what this green arrow is saying is that that's what all of the numbers that x can be is. So this right here is the number line solution. And then the third way to write it is going to be called interval notation, where we can say that x is going to be any number that's less than negative 3, so that means x is going to go down to negative infinity. From negative infinity, we can go to negative 3. Now, the end point, you see how this is a parenthesis, is because, you can't be infinity, so we put a parenthesis there. However, this is saying that x is also equal to negative 3, therefore we write down the interval using a bracket. And then this one is going to be the third way we write down our answer. So now that we found all of our answers, this example is complete. Example number 2, we want to go ahead and solve this problem right here. So, like before, what we want to do is get x by itself. That means I want to add 5 to both sides, because that's the opposite of subtraction. And when we do that, these 5s cancel. And what we'll have left over on the left-hand side is negative 2x is greater than 9 plus 5 is 14. Now, to get x by itself, since it's multiplied by negative 2, we have to divide by negative 2 to both sides. That means these negative 2's are going to cancel, so we're going to have x. And now, the tricky part about this is whenever you're going to be dividing by a negative, you change the way the sign is pointing. So right now, you can see how it's pointing to the right. We changed the way it points, so now it's going to point to the left. And then 14 divided by negative 2 is going to give us negative 7. So this is one of our answers here. Now let's go ahead and draw the number line, which will look like this. And I'm going to say this right here is 0, and this right here is negative 7. Our answer says that x is less than negative 7. Since there is no equal to sign, I'm going to put a unshaded circle around negative 7 because we know our answer is not equal to negative 7. And x is going to be all the numbers less than -7, so it's going to be pointing to the left. This right here is the completed number line solution. Now let's go ahead and write down our interval notation. So it's going to be the same thing as before. X is going to be all the numbers less than -7, and that's going to go all the way to -infinity. And then it goes to -7. But however, x does not equal -7, therefore we include a parenthesis on the end. So this is going to be our interval notation. Now we found all three of our answers here, therefore this example is complete. Example number 3, we want to solve this problem right here. Like any other problem, what we want to do is get all of the x's by itself. I usually like getting the x's to be on the left hand side and everything else on the right hand side, but either way your answer is going to be the same. So first let's start by moving this -3x to the left hand side. To do that, we do the opposite. This is -3x, so that means we're going to add 3x to both sides. Like that. Now, these 3's cancel, and what we have left over is 5x plus 3x, which gives us 8x minus 12 is greater than 8. Now, we have to move over this -12 here, so we do the opposite, which is add. So plus 12 plus 12. These 12's cancel. And now we have 8x is greater than 8 plus 12 is 20. To get x by itself, we divide by 8. Divide by 8. The 8's here cancel. And we're going to have x is greater than 20 over 8. From here, what we're going to do is reduce, and 4 can go into both of these numbers. So that means that x is going to be greater than, if we take away 4, or if we divide 20 by 4, we'll have 5 left over. And if we divide 8 by 4, we'll have 2 left over. So this right here is going to be one of our answers. X is greater than 5 over 2. Let's go ahead and show the number line. So I'm just going to draw a line like this with 2 arrows. I'm going to say this is 0, and then this right here is going to be 5 over 2. And what our answer is saying is that x is going to be greater than all of the numbers higher than 5 over 2. Since there's no equal sign, that means we put a circle that's unshaded. And then x is greater than all of these numbers, that means we're going to draw an arrow to the right. So this right here is our number line solution. Now let's go ahead and write this in interval notation. So we're saying that x is greater than all the numbers larger than 5 over 2, so that means we're going to start with 5 over 2. And since x is not equal to that, we're going to have a parenthesis, comma, and then it goes to infinity. All of the numbers greater than 5 over 2. Like that. This right here is our interval notation. So we found all 3 ways to write down our solution, therefore this example is complete. Example number 4, we want to go ahead and solve this problem right here. So we'll always begin first by doing the parentheses. So we're going to distribute the 3 that's on the outside to every number on the inside here. So 3 times 7 is going to give us 21, minus 3 times -2x, it's going to be 6x, plus 6x is less than or equal to 5x minus 4. Now let's go ahead and combine like terms. We see that on the left hand side we have -6x and we have +6x. So these, when we add them together, they're actually just going to cancel. What we'll have left over is 21 is less than or equal to 5x minus 4. From here, we want to get the x by itself, so that means I have to move this negative 4 over to the other side, and we do that by doing the opposite, which is add 4 to both sides. When we do that, we have 21 plus 4 is going to be 25 is less than or equal to 5x. And now to get x by itself, what we do is do the opposite of multiplication, which is divide. So we're going to divide by 5 to both sides. This 5 and this 5 are going to cancel. And what we'll have is that 5 is less than or equal to x. Like that. So this is going to be one of our solutions here. Now let's go ahead and look at the number line solution. So here is 0, here is 5, and in this problem it says that x is greater than or equal to 5. I know that usually we'll have x on the left hand side, but I wanted to show you how it looks like with x on the right hand side. And you can see that it's saying that x is going to be greater than 5. Or if you want to read it from left to right, it's saying 5 is less than or equal to x. So since we have the equal sign there too, that means we're going to go ahead and have a circle around 5, but it's going to be shaded. Now it's saying that 5 is less than or equal to x, so that means that x has to be bigger than 5. Therefore, our arrow of our solutions is going to go to the right. And what we can do to, I guess, help clarify this is you can actually just rewrite it. So it's going to look like this. X is greater than or equal to 5. All you do is you kind of just flip it over. So that makes it a little bit easier to visualize what's going on here. So this right here is our number line solution. Now let's look at our interval solution. So we're going to start with 5, and it says that x is greater than or equal to 5. Since there it is or equal to, we have to put a bracket there. And x is going to be all the numbers greater than 5, so that means it's going to go to infinity. And whenever you have infinity here, that means you're going to have a parenthesis as the end bracket. So this right here is our interval notation of the solution. So we found all 3 ways to write down our solution, therefore this example is complete. Example number 5, we want to go ahead and solve this problem right here. Now this is just like the other problems, except now we have 2 different inequalities in one. However, we still solve it the same. But in this case, we want to have our x term stay in the middle between the 2 inequalities. So we want to isolate x by itself, but we want it in the middle. Let's go ahead and do that. We see here that it's 2x minus 1, so we want to move this 1 out of the middle. To do that, we still do the opposite, which is add 1. But now we have to add 1 to both sides. So we have to add 1 over here on the other side of the inequality, and over here on the left side of the inequality. Just like that. So these ones here are going to cancel. And now from left to right, we have negative 5 plus 1 is negative 4 is less than or equal to 2x, which is less than 9 plus 1, which is 10. Yeah, so the only thing that you have to remember with these kind of problems is that you have to add it to both sides. Whatever you do, you have to do it to both sides of the equation. So now we have 2x in the middle. To get rid of the 2, what we have to do is divide. And then we have to divide the right side and the left side. Like that. These 2's are going to cancel in the middle. And on the left-hand side, we have negative 4 divided by 2, which is negative 2 is less than or equal to x, which is less than 5. So now we've isolated x. This right here is one of our ways to write down our solution. Now let's look at a number line. So I'm going to draw a number line just like this. And before, we usually only had to write one number down, but in this case we have to write down two numbers. So 0 is going to be there. I'm going to say this right here is my 5, and I'm going to say that this right here is negative 2. So let's read the problem out loud. Negative 2 is less than or equal to x, which is less than 5. So let's work this kind of like we'll look at one side and then look at the other side. So this is saying that negative 2 is less than or equal to x, or that x is greater than or equal to negative 2. So that means that x, it can be negative 2 because there's the equal sign there, so we're going to shade that. And then our answers, x is going to be greater than negative 2. Now if we look at the right hand side, it says that x is less than 5. Since there's no equal sign there, we're going to have to put a circle, an unshaded circle, around the 5. And it's saying x is less than that number, so that means our arrow is going to go to the left. So as you can see here, our solution, if we want to visualize this, is going to be every number between negative 2 to 5. So it's going to be this whole shaded area. So that right there is the number line solution to this problem. Now let's look at the interval notation. We're going to have two different kind of sets here. So looking at the left hand side, we know that negative 2, x can equal that. So we're going to have a bracket from negative 2, and we're saying that it can go up to 5. Since if you look at our number line, it goes from negative 2 to 5. Negative 2 can be a solution, however 5 cannot since there's no equal sign there. Therefore, we're going to have a parenthesis at the end. And this one right here is our interval notation for this problem. Now that we found all three ways to write it, this example is complete.